Hi, my name is Ali Arana binti Samsuri and I am going to present a research proposal with title Water Treatment to Remove Orange 2-Dye Compound using a Homogeneous Fe-TAML Catalyst and H2O2 System. Dye pollution is a pressing environmental issue caused by the discharge of colored dyes into water bodies from various industrial sectors such as textiles, printing, and dye manufacturing. Orange 2 is one of the commonly used azo dyes in this industry. The Fe-TAML Catalyst H2O2 system is a specific type of advanced oxidation processes used to remove organic pollutants, including dyes from water sources. Orange 2 dyes pose a significant environmental and health concern due to their discharge into water bodies. The existing dye removal methods, including physical adsorption, chemical precipitation, and biological degradation, have limitation in applicability to a wide range of water sources. Therefore, there is a need for an effective and sustainable method to remove orange 2 dyes from contaminated water sources. The objectives of this study are first to determine the best parameter to oxidize orange 2 dye using a homogeneous Fe-TAML catalyst and H2O2 system by UV spectrometry. Second is to observe the removal of orange 2 dye compound using the HPLC method, and lastly, to test the toxicity study of the byproduct formed by using MTT assay. More than 100,000 dyes available commercially and 700,000 tons are manufactured, with textile sector being the most significant contributor to release dyes into water bodies. Orange 2 dye with chemical formula C16H11N2NaO4S has a structure consists of aromatic rings connected by a diazo group with a sulfonic acid group attached to one of the aromatic rings. Orange 2 dye are synthesized by diazotization and coupling reaction. For previous study on dye removal method, physical method involves are adsorption, filtration, separation, and sedimentation, while for chemical methods involves are oxidation, ozonation, Fenton reagents, and electrochemical destruction. This system involves the use of Fe-TAML catalyst in combination with hydrogen peroxide. The system operates under mild conditions such as near neutral pH and ambient temperature while minimizing the formation of harmful byproducts. The synthesis of homogeneous Fe-TAML catalyst involves the combination of TAML ligand and iron trichloride in ethanol to form Fe-TAML complex. For the preparation of orange 2 dye, the dye powder are dissolved in methanol, and from the stock solution, it is diluted into 5 different concentrations to be used for subsequent dye removal experiment. To remove orange 2 dye, a homogeneous Fe-TAML catalyst is added to the dye solution and allowed to equilibrate. Once the equilibration period is completed, hydrogen peroxide solution is added to activate the catalyst. After 30 minutes, catalyst was added to terminate the reaction. The results which were expected to obtain are the degradation of orange 2 dye, which was identified by the color change. The dark orange color solution was changed into a light orange solution and became colorless at the final stage. The degradation of orange 2 dye can be observed by analyzing the absorption spectra using UV spectroscopy. A gradual decrease in color intensity and absorbance indicating the degradation of dye, which confirmed by UV spectra. High-performance liquid chromatography (HPLC) analysis is a technique that was utilized to detect and quantify the amount of orange 2 dye that is still present in the solution after being oxidized. In addition, the retention time and spectral characteristic obtained from the HPLC analysis can be used to confirm the identity of orange 2 dye.